You know that moment when you have to make a decision and you know full well what you should choose, but for some reason you still ended up choosing the wrong thing. You knew better. You knew you had to go to bed early. You knew you shouldn't have gone to the party. You know you shouldn't have been on your phone the whole time and you should have worked. But for some reason you still did it anyway. You watch yourself and it's like a part of you has already decided what it was gonna do. So are we really in control? What if free will is not actually what we think it is, or does not work how we think it does? What if the brain already starts a decision before we feel it, before we become consciously aware of it? Well, that's exactly what we'll be exploring in this video. We will see what free will actually means, what the science says about free will, and how we can apply this psychology in our daily lives to take back control so we can live a life worth living. So, what do we actually mean by free will? Well, basically, it's the ability to choose freely without being forced. It's a combination of the two words free and will. And free means not controlled by something else, and will means your inner power to decide, to act, or to choose. What this really means is that if you have free will, you can choose between different options. There are multiple options available. It also means that because you have multiple options available, you could have done something else, and that the choice comes from you and not from any outside pressure or a reflex or an instinctual behavior. For example, if you decide to quit your job because it feels right for you, even if others disagree, that's free will. You chose because you wanted it. But if someone forces you to quit, like you're being fired or you're being bullied, that's not a choice, that's coercion or force. If you raise your hand to answer a question in school, that's a conscious choice, a conscious decision. But if your leg moves when you're at the doctor and he hits your knee with a hammer, that's your nervous system reacting. That is not willpower, that's just a reflex, an instinctual reflex. So, how does this all actually work? Well, for this we have to go back to the 1980s. There was a neuroscientist called Benjamin Libet, and he wanted to figure out one big thing. He wanted to know, does your brain start an action before you consciously decide to do it, before you consciously become aware of it? He did this by asking people to sit down, just relax, and to move their wrist whenever they felt like it. No countdown, no cue, just a spontaneous flick, spontaneous movement of their wrist. While they did this, they also had to watch a fast spinning clock. And after each movement, they had to tell when they felt the urge to move. So look at the clock and say the exact moment they felt the urge to move. This moment Libet called W time, and the W stands for will. So the moment of will, the will to move. So, how did he measure this? Well, he used two simple machines. The first one is an EEG, and this is a machine that measures brain activity using small sensors that are placed on the scalp, and it can pick up faint electrical signals when neurons fire. The second one was an EMG, and this is a machine that measures muscle activity, so it can show the exact moment the wrist of the person moved. With this information, Libet could compare when the brain started preparing electrically, when people felt the urge to move, and when the body actually moved. And what he found was quite shocking. The brain showed a clear buildup of electrical activity about 350 milliseconds before the wrist moved. This moment is called the readiness potential. But people only felt the decision to move around 200 milliseconds before the movement. So it looks like the brain was already getting ready roughly around 150 milliseconds earlier than the person said they were aware of their will to move, the W time as I mentioned. So what are the implications of this? Well, on the surface it sounds like this. Your brain decides before you do. And some people looked at this and obviously thought it meant that free will is just an illusion. But Libet himself disagreed with this. He said that we can still veto an action before it happens, and he called this the free won't. So, yeah, we might not start every action consciously, but we can still choose to not follow through on the action. So, as you can imagine, this experiment made a big splash in the scientific community. And of course, there were other scientists that wanted to test this more carefully. Well, did they find the same thing? Generally, yes. Many studies in the 1990s and in the early 2000s tried to replicate the results that Libet found. They made some small changes to improve the setup, and they asked questions like, can we measure W time, the moment of intention, more precisely? Can we remove distractions or biases in the clock method? And does the readiness potential still appear in other kinds of tasks, so other things than just tricking the wrist? And yeah, the answer was usually yes. The brain still showed signs of preparing a movement before people said they consciously chose to move. Some researchers looked even closer, especially at the timing and shape of the readiness potential signal. So again, the electrical signal in the brain that they recorded with the EEG, and they generally found the same pattern. The readiness potential reliably shows up before simple voluntary actions like finger taps, wrist flicks, etc. And again, it starts a few hundred milliseconds before the moment people feel the decision, before they consciously become aware of this. So, what did these results confirm? Well, they confirmed that Libet's findings, his findings, were not just a fluke, not just a one-time thing, and that even with better tools and stricter experiments, these results still held true. So the brain starts getting ready before we become aware of the decision. But researchers also noticed something important. These results mostly apply to simple, quick decisions, like tapping a finger or wriggling the wrist. They might not tell us the full story when we're talking about complex and thoughtful choices, because deciding what to eat for lunch is obviously not the same thing as choosing what career you should follow, or if you should break up with your girlfriend. After these experiments, researchers said, okay, the brain starts preparing a few hundred milliseconds before we feel it, before we are conscious of it, but how far back does this go? Scientists decided to test this with some newer and better technologies. In 2008, a team led by Chung Xiong-sun in Germany ran a now very famous study. They put people inside an fMRI scanner, and this is a machine that maps brain activity using blood flow. Participants had a simple task: press a button with either your left or your right hand whenever you want. And just like in the setup of Libet, they had to report the exact moment that they felt the decision was made. So, what's the difference here? Well, unlike an EEG, which tracks fast brainwaves, an fMRI shows where in the brain things happen. The researchers used AI and machine learning to look at small patterns, tiny indications that could predict which hand the person was going to choose. And also this even before they became aware of it. So, what were the results? Well, this algorithm could predict the choice the person was going to make up to 7 seconds before the person felt it. The accuracy was around 60%, so it's obviously not perfect, but it's clearly better than a random guessing, which is 50%. So the brain seemed to be leaning towards a certain decision long before awareness kicked in. And not just milliseconds like in the earlier experiments, but seconds before the choice was consciously made. So where in the brain did this all take place? Well, these signals were shown in the prefrontal and the parietal cortex. And these are areas that are tied to planning and attention. Higher order areas where complex thoughts seem to take shape. So, these findings pushed the debate around free will further. Maybe the brain doesn't just prepare before we act. Maybe it's already biased towards a certain choice seconds before we notice it or become consciously aware of it. But obviously this opens a new question. Are these really decision signals that they measured? Or are they just random brain noise that we later interpret as being the choice or the moment of choice? So after the fMRI studies showed that decisions might be predicted seconds in advance, scientists wanted to look closer. They wanted to look not just at brain regions, but at individual brain cells. They wanted to know if we can actually see a decision forming before a person becomes consciously aware of it. And this is exactly what happened in a 2011 study by Itzhak Fried and his team. So, how did the experiment look? Well, they worked with a few epilepsy patients who already had tiny electrodes implanted in their brains for a current medical treatment. And these special electrodes could do something interesting. They recorded signals from single neurons, so literally individual brain cells firing. And the task in this experiment was very simple and familiar. The participants had to press a button with their left or their right hand whenever they felt like it. So just like in the earlier experiments. The researchers wanted to know, is there a neuron that fires before a left-hand choice, and is there another one that fires before a right-hand choice? And is this difference measurable? And how do they activate before a person even feels the decision, feels the conscious decision of what they were going to do? So, what did they find? Well, yes, certain neurons in regions called the medial frontal cortex became active. And this was before the person knew which hand they were going to use. The medial frontal cortex is a part of the frontal lobe, and this is involved in decision making, self-reflection, emotional regulation, and performance monitoring. So, some neurons fired more before a left-handed choice, and others fired more before a right-handed one. And all of this happened roughly around 1 second before the person pressed the button, and well before they reported feeling making the decision. What is important to note here is that this was a very small study. There were only around a dozen participants. So while it's powerful, it's indicative, it's not yet universal proof. So why did these results matter? Well, it showed that even at the single cell level, the brain already seems to start preparing a decision before the conscious awareness happens. And this added a new layer of evidence, and that not just large brain regions lighted up or fired up before making a decision, but specific neurons quietly were getting ready behind the scenes before making a decision. You can look at it like it's a car that's already revving up before you press the gas. Would be weird, right? So, after years of experiments showing basically the same thing, some scientists said, wait a second, are we actually seeing the decision in the brain, or could we just be misunderstanding what's going on? Well, in 2012, there was a neuroscientist called Aaron Schurger, and he offered a different idea. He said that the readiness potential, so the slow buildup of brain activity that Libet had discovered years prior, might not show the decision signal at all. It could just be what happens when the brain's normal background activity randomly reaches a point that triggers the movement or triggers the decision. Think of your brain as a machine that is always buzzing in the background. It's always on, even when you're not doing anything, when you're sleeping. It's always full of electrical activity and flickers and random neural noise. So now imagine that you are told, move your hand whenever you feel like it. So, you wait, and at some random moment, the brain noise builds up enough to make you move. And that's it. That's what he said. And he called this the accumulator model. It's like having a bucket of water, catching random drops, and when it reaches the top, when it finally fills, you act. And if you average out hundreds of these moments together, those random drops of water, they form a smooth curve. And this looks like the readiness potential. So what Libet saw might not be the decision signal, but just average pattern of when random brain noise hits a certain tipping point. So what does this mean? Well, if Schurger is right, and I'm not saying he is, but if he's right, then the readiness potential doesn't mean the brain has already decided before you do. It means that it might just show that the brain was getting close to acting, to doing something. It's a sort of readiness, but not a final choice. And in this case, consciousness could still play a role, a decision-making role, like deciding when to move or holding back instead of acting right away. And there's another issue too, the so-called W time, the time of will, the people wanted to move when they looked at the clock. This measurement is not very reliable. Why? Well, because our sense of time, especially within a second or in the millisecond range, is pretty blurry, not really accurate. And in the experiments of Libet, people had to watch a fast-moving clock, and then they had to report when they felt the urge to move. But our attention, expectation, and even small changes of wording before the experiment can shift these answers or these moments by a lot. They've tested this. So the timing of awareness might not be as precise as we thought. So now we end up having two big issues. First is that the brain signal might not actually show the decision being made. And second, that the moment we say we felt the decision might not be trustworthy. So together this means that the Libet's experiments do reveal something real, that the brain starts preparing before an action, but it does not necessarily prove that free will is an illusion. So maybe the brain is just noisy, and timing is very difficult to measure, and maybe our sense of control is more complicated than just brain first, mind second. Okay, so maybe the brain starts preparing an action before we are aware of it, and maybe not. But the real question is, can we still stop ourselves, even if the brain has already started the process? Surprisingly and luckily, yes. Neuroscience shows that the brain actually has its own braking system, and it works pretty fast. One of the main ways scientists study self-control is with the stop signal test, and it works like this. The subjects see a go signal, for example, an arrow or just go on the screen, and they have to press a button as quickly as they can after they see this go signal. But sometimes a stop signal flashes right after the go signal. And the challenge of the subject is they have to try to cancel the movement, even though they have already started preparing it. It's kind of like starting to say something and then catching yourself mid-sentence and stopping it. You probably had this in your own life. I have. So how does the brain's braking system actually work? Well, when you stop yourself like that mid-sentence, there are several brain regions that kick in together. The first one is the right inferior frontal cortex, and this acts as the brain's brake lever, just like you have in your car. Second, we have the subthalamic nucleus, and this is an area that is located deep inside the brain, and this helps interrupt or cancel movements that are already set in motion. And third, we have the pre-supplementary motor area, and this detects the stop signal and helps trigger the brake. These areas form together the fast brake network, and this can shut down actions even after they have started to move through the system. In other words, once the brain begins preparing an action, it can still veto it. It can still stop before it reaches our muscles, luckily. So, now that we know this, how fast can we stop this? Well, scientists measure something called the stop signal reaction time. In short, this is SSRT. And this is how quickly your brain can hit the brakes after seeing the stop cue in the experiment that we talked about. For most people, this is around 200 milliseconds, or about 1/5 of a second, pretty fast. But some people have a faster or slower brake system than others. And it's dependent on stress, fatigue, and even training. Because yes, it can also be improved. Practicing inhibition tasks or mindfulness/meditation can strengthen stopping ability, and it's just like training a muscle. We also have some real-life proof using deep brain stimulation. In Parkinson's disease, doctors sometimes implant electrodes in the subthalamic nucleus to help control the movement. And when researchers adjust the activity in that region using DBS, deep brain stimulation, with zaps, the ability of the people to stop their actions actually changed. And that's real world evidence that the subthalamic nucleus is not just used for movement, but is also crucial for stopping movement. So what does this mean for free will? Well, even if unconscious brain processes start an action, we can still pause, we can still rethink, and we can still cancel it before it's completed or really set in motion. The preparation does not mean that the action is inevitable. The brain has a real-time override system, and it's not total control, but it's meaningful control, especially when we practice awareness or self-regulation. So maybe Libet was partly right. We don't have perfect free will, but we do have free want. Here's something strange. Even if scientists can show the brain was already preparing a decision before we are consciously aware of it, we all still feel like we chose it freely. So why is this? Well, it's because the brain doesn't just act, it also explains. And sometimes those explanations aren't actually true, or at least not 100% true. Let's look at a few examples for this. In some rare medical cases, often to treat severe epilepsy, surgeons cut the corpus callosum, which is the thick bridge of fibers that connects the brain's two halves. And once this connection is gone, each hemisphere kind of works like it's his own person. The one side controls the left side of the body, and the other side controls the right side of the body. So scientists tested these persons. They showed different images to each half of the brain. For example, one picture to the left eye, which is controlled by the right hemisphere, and another one to the right eye, which is controlled by the left hemisphere. And what happened was pretty interesting. The right hemisphere, which cannot speak, used the left hand to grab an object that was related to what it saw. And when the left hemisphere which can speak, was asked by the researchers, why did you do that? Why did you pick it up? It had no idea, because there's no connection between the two halves. But it still made up a reason. It said something like, oh, I just felt like picking it up. This strange phenomenon is called confabulation, and it's the brain inventing a story to make its action feel logical, to make it fit into the world. And the amazing part of this is that the person is not lying. The speaking brain believes the story it has just created. Second experiment was the face experiment. In this experiment, people were shown two faces, and they were asked which one of these faces they found more attractive. After they had made a choice, the researchers secretly switched the photos, and the participants didn't know this, they didn't notice this. And when they were asked to explain their choice, they confidently explained why they chose the face they hadn't actually chosen. So once again, the brain filled in a story that felt true, even though it wasn't. Third, our memory is not a hard drive. We like to think that our memory is a perfect recording, but it's not, really not. Every time we recall something, the brain reconstructs it. Details change, details can disappear, or they can be added. And this all without us realizing. So even our memories of why we chose something are not always 100% reliable. The fourth one is also really interesting. Some people with brain damage, after having a stroke, lose the ability to move an arm, so they're paralyzed. But they will still insist that everything is fine. They will say things like, oh, I'm just resting my arm, or it's cold today, so that's why I'm not moving it. And these people are not lying, even though you might think they are. Their brain is just protecting their sense of self. It's filling in a story to make the world feel normal again, because it's quite a big change if you are suddenly not able to move your arm anymore. So, what does this all mean? Well, it means that your brain doesn't just make decisions, it also makes sense of them and sense of the world. Even when those decisions start unconsciously, your brain will still act like it fits into the narrative. We are storytellers. We are constantly stitching together a narrative about the world and who we are. And this story feels real, even when it's not entirely accurate. So the next time you think, oh, I made this decision consciously, it might be worth asking yourself, did I really? Or did my brain just decide and hand me the story or the script afterwards? Okay, so the science shows that the brain often starts preparing actions before we are aware of them, and then afterwards it builds a story to explain why we did and what we did. But that's pretty weird, right? Why not just give us the full control from the start? Well, the answer might be that this system, confusing as it may sound, actually works really well for survival, which is obviously the driving force in evolution. Imagine if your thoughts, actions, and memories felt totally disconnected from each other all the time. This would be really, really confusing. You would be confused, but the people around you would also be confused. They wouldn't trust you because, yeah, you wouldn't even know who you are and where you are. So this is why the brain keeps things coherent, even if it has to fill in a few blanks some of the time. And it gives you a consistent story about yourself and about the world. So you can tell yourself, oh, I chose that. I did this because, and I know who I am because, and this is important because, yeah, even if the story isn't always 100% accurate, it's still good enough to function, good enough to feel stable. Otherwise, we wouldn't have been here. Secondly, humans are also very social animals. Being part of the group used to mean survival. It was essential. And society runs on explanations. We constantly have to justify what we do and why we do things. Yeah? People say, why did you do that? Why did you say that? What made you do this? Or what made you do that? And if you would always answer, I don't know, people would really not trust you or follow you for that matter. So evolution may have shaped our brains to create reasons, to explain intentions, to look consistent and rational, even if the real decisions started unconsciously. We are built to look like we're in control, even if control is messy behind the scenes. I call it the fake it until you make it, and biologically speaking. Even if we don't consciously start every action, we still have the power to think ahead. We can imagine futures, we can rehearse our choices, we can visualize outcomes, we can even dream and simulate the reality in our dreams to prepare. And that's massive for survival, and it's something humans are especially good at compared to other animals. So maybe the conscious mind isn't the one pushing the first domino, but it is the one looking down the line and saying, if I do this now, where does it lead? What would happen? And that kind of forward modeling makes us flexible, makes us creative, and makes us adaptable, which is one of the most important things for survival. So, is free will real? Well, maybe not in the way we grew up thinking about it, but it does not mean that we have zero control. A better way to think about it is not like an on-off switch, yes or no, but more like a dimmer. Sometimes it's shining at full power, at full brightness, and other times it might not be as bright and not be as powerful. This all depends on the kind of decisions you are making and on the state that your brain is in and your body is in. So what are the moments when our free will shines brightest? Well, at first it is the deliberate choices. When you pause, when you weigh your options, and when you think through the consequences. And you do this when changing a job or ending in a relationship. Also when you have slower paced decisions, when you're not rushed, when you have all the time to reflect and to think. Third is with abstract or moral questions, choices that are tied to your values, your ethics, like apologizing, donating, or doing the right thing. Fourth, the goal-directed choices, when you're planning carefully and acting with intention. And fifth, the self-monitored choices, when you notice your habits and you try to resist them, like stopping with smoking or breaking certain habits. During these moments, the prefrontal cortex, the brain's thinking and planning area, is most active. And this helps you slow down, weigh your long-term goals over your short-term impulses, and act with intention instead of with instinct, instead of automatically acting. So in short, you are less reactive and more reflective and active. Now, let's look at the situations where unconscious processes tend to take over. When you have fast and reactive choices, like instant responses, no time to think, like getting angry in the midst of an argument. Also, when you're tired, distracted, or very stressed, your brains tend to switch to the autopilot. Also, when you're very emotional, strong feelings take over your reasoning. Habitual behavior, of course, automatic loops like checking your phone 100 times a day. Also, when things are heavily influenced by context, when the design of an environment nudges you, like social media, casino layouts, or clickbait titles like this one. In these cases, the subcortical systems take over the wheel, and these are areas like the basal ganglia, which is involved in habits, and the amygdala, which is involved with emotions. So in these cases, you're not really choosing, you're more reacting, more instinctive acting. So what does this all mean for us? Well, this view gives us something realistic, but also empowering. You're not in control of everything all the time, but you can still create the conditions that make conscious control more likely. If you are wondering how all this science adds up to something that feels like free will, you're not alone. Let's tackle the biggest questions one by one. If my brain starts before I'm aware, do I have any free will? Well, yes, but maybe not where you think. You might not always start the action, but you often have the power to interrupt, adjust, or guide it. It's like sailing. You cannot control the wind, but you can adjust your sails to catch it better, to steer, to direct. Does the brain prediction mean everything is predetermined? No. The predictions in these studies are statistical and they are not absolute. If a computer model can predict your choice with 60 to 70% accuracy, that's better than random, but it's not fate. It's not predetermined, it's not set. Just means that your brain has a biases and some patterns, but you're not a robot and you still have room to move, especially when you're reflecting and when you're aware of it. So, what kind of decisions are still mine? The more deliberate, value-driven or long-term a decision is, the more likely your conscious mind is really involved. So picking what to eat when you're starving? Now, mostly a habit. Deciding how to end a relationship? Mostly a conscious reflection. Both are part of life, but they are not equally conscious. You are not experiencing them in the same way. Is the veto real? Can we actually stop ourselves? Yes. There is strong evidence that the brain has a built-in braking system. The right inferior frontal cortex and the subthalamic nucleus help you cancel your actions even after they have started preparing. So, in the brain, but before they reach your muscles. You cannot always stop instantly, but you can often delay, redirect, or pause your action. And that's all that matters. So, in short, free will isn't about total control, it's about influence. It's about the ability to shape, to steer, and to sometimes stop when it's needed. Even if the brain starts first, you still get a say in how the story ends. So, now we know that your brain sometimes decides before you do, and that your conscious mind isn't always in the driver's seat. But that does not mean that you're powerless, not even close. You can still shape what happens next. Here's how you can apply this psychology in life. The first one is build in a pause. The biggest tool we have is time, even if it's just a short moment. Count to 3 before you respond to something when you are high in emotions. Take a deep breath before deciding. And ask yourself, what is the long-term move here? So that tiny pause gives your conscious mind a chance to catch up with your instinctual impulses. It's the moment where free will sneaks back into the decision. Second one is make habits do the work. Most of our daily actions come from habits, so train them and use them on purpose. If you don't want to check your phone in the bed, charge it outside of your room. If you want to eat healthier, make the healthy option the easy one. Don't buy unhealthy stuff, don't have it in your house. Don't depend on willpower, but design your defaults, because we only have a very limited amount of willpower every day. As James Clear says, you don't rise to the level of your goals, but you fall to the level of your systems. If you cannot always control the moment, try to control the setup. Third one is to reframe your inner language, the way you talk to yourself. The words you use in your head do really matter. So, for example, I can't eat that becomes I don't eat that. And I have to do this becomes I choose to do this. Tiny phrasing shifts can have big mental differences. They turn resistance into ownership, and ownership supports control. The fourth one is to protect your mental state. The conscious control we have is weakest when we are tired, when we are overloaded or stressed. So this means that try to get enough sleep. Manage the amount of time that you are on a screen, on your phone or your laptop or whatever. Say no when your plate is full, in social situations or at work. Because when our brain is rested, the editor, our reflective self, it has room to do its job, to do what it's used for, consciously controlling your decisions. The fifth one is to design the environment for slower thinking. Make it easier to think clearly by reducing noise and distractions. Remove these distractions during meaningful work. Make the big decisions in the morning and not at midnight or not when you're drunk at a party. Use gentle reminders and check-ins to stay aligned with your values and your goals, because the slower you think, the freer you are. And the last one is to practice saying wait. If something feels very urgent, very emotional or automatic, try to say, wait, let me get back to you in 15 minutes. And just this one tiny line can create enough space for your free will to come online. So the final thought is that free will isn't about being in control all the time. It's about creating the conditions where you have the most influence. The more you pause, the more you reflect and design your life with intention, the more your choices become truly yours. And that's applied psychology.